Good afternoon and welcome to this session on automating security for the real-time enterprise. My name is Chris van den Abel, or Van den Abele, as they say at home in Belgium, Europe, where I live. I work for Trend Micro, so this is a so-called sponsored session, so it's going to be a little bit tainted from a partner perspective, from a product perspective. But I will try to minimize the salesy part of the presentation and try to focus on value, try to focus on real takeaways. And I would say you could look at this session on 3 different layers. Like layer 1 would be, we talk about concepts about automated security. We talk about the issues that you have when you are using bolted-on security, security after as an aftermatch, actually. And layer 2 would be, now we know about those concepts, how can we put those in reality? How can we make this happen? And I will illustrate that with demos, and for that I will use the Trend Micro product, Trend Micro Deep Security. And then layer 3 of the presentation would be, just to make sure I'm not telling fairy tales here, I am joined by Kelly from Plexus, and Plexus is an esteemed customer of us, and Kelly will talk about how they actually put in production our product with those concepts. And so I guess layer 1, 2, and 3, it all makes sense, and it gives you a perspective. So even if you're not interested in the real product pitch, you still can have several takeaways from this. So maybe Kelly, you can talk about you and Plexus.
Sure. Good afternoon, everyone. My name is Kelly McBriar. I'm an infrastructure architect for Plexus Corporation. I've had the good fortune of working for Plexus for the last 22 years, the last 10 to 12 really being in a virtualization-focused role, right? 10 years ago, we started introducing Trend Micro into our security suite with our first install of Trend Deep Security in 2012. Before we get too deep into the product, I wanted to give you just a quick background to give you some context around who is Plexus. We are an electronics manufacturing and engineering company based out of Neenah, Wisconsin. What we do is we take ideas from customers and work with them to design, engineer, manufacture, and take things into aftermarket services. So a good example of this might be Coca-Cola. Coca-Cola is not really known for having a large electronics division, so they partnered with us in order to design and develop, as well as manufacturing and provide those aftermarket services for the Coke Freestyle machines. You might see them in a lot of restaurants today. To the left of the Coke machine up there, you can see like healthcare, life sciences. This is where we begin to get not only into the intellectual property. You know, Coca-Cola is certainly well known for maintaining the Coke secret, right? You know, has an emphasis on that. But we get into not only customer information, but also regulatory information, right? FDA with the life sciences. And then as we move into the defense, security, and aerospace field, that's where we get into like NIST compliance. That's where we have DFARS regulations, FARS regulations. And Trend Micro is an area that really comes into play here to help protect our information.
Okay. So the obligatory slide on Trend Micro. So who is Trend Micro? Very, very quickly. We are in IT security for 28 years. We only focus on IT security. We are the #1 partner for VMware environments. We are the #1 partner for cloud environments. Those are our 2 strong capabilities, so to speak. What else? We are headquartered in Tokyo, and important, 45 of the 50 global enterprises are a customer of Trend Micro. So, I mean, just some background. Now, the agenda of the session, introductions, we've done that. Automated security from bolted on to becoming part of the fabric. I think that is going to be like the main part of the presentation. And then we will have a little side leap to making the business case for automated virtual patching. If you are not using automated virtual patching today, I think this is something you really have to look at. It is almost a no-brainer. It increases your security, and at the same side, it can lower your operational cost. So it's really a win-win thing. And we will cover how to make the business case on this and why this is so interesting, actually. Then we have some parts.
Right. So after that, I'm going to get into kind of how the story has changed a little bit for us at Plexus as far as what does Trend Deep Security mean for us, what does it do for us. VMware, with the NSX integration, really becomes kind of almost a middleware company, right? So it's kind of an opportunity for us to glue together a lot of systems in order to innovate. We'll talk about vReal as operations as the native plugin there.
Yeah. Okay. So let's have a look at integrated security. When VMware introduced workload virtualization, on the operations side, we actually made a quantum leap. It now became so easy and so quick to create a new server. We snapped our fingers, we cloned an existing one, or we cloned it from a template, and within minutes we had a new workload ready to be used. If you look at the cloud, almost the same thing is the same capabilities we have in the cloud. If you want a new instance or a new workload, you go to the marketplace, you select one. If you want a full stack, like a LAMP stack or a mean stack, you go and you select it, you click it, and after a few minutes you have that capability. The same thing is happening with NSX and networking virtualization. Through virtualization, from an operational perspective, we get a kind of a quantum leap. We get a lot more capabilities. But then if you look at security, we see in many organizations, security is still something that is kind of living in the Stone Age. It is something that is done manually. It's something that's done as an aftermatch, as an after thing. And today, in the real-time enterprise, what do we see? Everybody has to do more with less. And if you do security the manual way, then this is often something that is kind of forgotten. Well, we have our workload, it is running, and the business is happy because, you are providing the service, and we will add the security. Yeah, we will do that afterwards. We will do that, maybe tomorrow or next week, and then you kind of forget it, and it's never done. So that's the main problem with bolted-on security, with security after the fact, so to speak. Now, applying security to new virtual machines or new workloads, it's like a 5-step process here. Step number 5 would be, if you want to secure something, you have to be sure that you can see it. And if somebody would ask you, how can you get visibility on your environment? You would probably say, well, I have a SOC, with security operations dashboard, and I can see the security status of my environment. Well, but actually the SOC shows you security after the fact. It will tell you this machine was attacked and that there was a potential security incident on this machine. But if you want to have a view, a single pane of view, a single pane of glass view on the security posture of your environment, then that's something else. You'll have to figure out, okay, I have my firewalls, I have my IPS settings, I have my antivirus, and so you will have to kind of integrate all of that information to get that view. And then you should ask yourself, okay, am I seeing really all of my machines? What about the machines that are not protected? They are kind of, shuffled under the carpet. We don't talk about those because we don't know them. We don't see them typically in our dashboard. But mainly those have the biggest risk of them all, because you can get a false sense of security if you're just ignoring the VMs or the workloads that are not protected. So let's switch to a little demo here. And yeah, so I am in my vCenter here, and you will see I have configured a series of folders. And I go to the Trend Micro Deep Security product here, and let me make this all a little bit bigger. There we go. I go to computers, and you will see here I see my vCenter, and I see exactly the same folders in there. So, and also, not to forget, I see my instances in the cloud, be it AWS or Azure. And this is this kind of leans towards the aspect of business users can sign up with a credit card and set up workloads or instances in the cloud, and they kind of remain under the radar. This is called like shadow IT. We as an IT person, we don't even know that those workloads exist until something happens. And then the big boss comes down and says, apparently we were breached. And then you say, were we? I mean, all my infrastructure, everything is spick and span, everything is protected. Well, there was something running in the cloud somewhere, and that was breached. Oh, yeah. Well, actually, it carries your company name. It is part of your enterprise, but if you don't see it, then you have a false sense of security. Now here, through all of those connectors, you just connect to the environment, and you have an instant view of everything that is running there. So whether it be protected or not, at least the step number one is that you can see it. So now let's go here, and I put on my operations cap. I am somebody from operations, and I will just create a new virtual machine, and I'm quietly not telling IT security about this. There should be a next button here. Yep, almost. Up, come on. Stay there. Up. The demo gods. Yeah. Okay, so I go next. Let's call it like Finance Server 3. Server 3, there we go. Next. I will put it in this data center, in this cluster on this ESX. And I will use this shared storage for it. And it's compatible with SAI3313BUS. And let's just make it a Windows one. And I just take all the defaults. I'm not really going to install an operating system. I just need to create an object here. And there it is. So my finance server is there. Now when we switch to the Trend Micro console and I go to finance, I have an instant view on that server, even though from a security perspective, we didn't touch it. We didn't do anything. This is all fully automated. We have a direct connection with vCenter, and we see that virtual machine instantly. So this brings great value because now no longer any VMs can remain under the radar. They cannot remain undetected because there is no agent installed, because they are not activated or something. If the VM exists in vCenter, we will know about it. That's like the #1 rule in security. If you want to protect something, you have to know that it exists. And I have screenshots of all the things, so if you download a presentation afterwards, you don't get the demo, but you can get some screenshots. Now, second step is I have seen this VM, I know it exists, so what is the context of that VM? If I want to protect it, I have to know, is this like our finance server with our sensitive data, or is this just maybe a server that we use to distribute and share our marketing flyers? Or is this a Windows machine or a Linux one or a database server or a web server? Or is it internet facing, or is it nicely tucked away inside of the data center? All of those aspects, they define the context of that machine. So again, we want to automate that. As an example, so you see here in the demo, we have just created that finance server. We created it in the folder finance, and it is a Windows machine. So if we look here, we see that Deep Security has automatically assigned the GT Win finance policy. And GT is the enterprise that I'm using here in the demo is green disk, so that's the that represents green disk. Then we have Win and Finance. It is detected as a Windows machine, and it is detected as being in the finance folder. So based on all of those, we apply specific security controls to that machine. And we will go a little bit more into depth on those security controls. So let's swap to here. So the way that we detect and we apply that policy is what we call event-based tasks in Deep Security. So you can see that over there. So the Deep Security product has an event system, and it can detect certain aspects and certain events that are happening. For example, vCenter tells us a new VM has been created. It was created in this folder. It has this and that operating system. And based on all of that, and I'll make it a bit bigger so you can actually see it. Based on all of those attributes of that virtual machine, we apply a certain specific security policy. So next, we have applied the security policy. Now let's do a risk assessment. And let's go back to a demo again. So I will take another machine because this one is not real, it's just an empty shell. Let's go to, I think I have a few in development here. So I have 2 web servers that we are currently building. They are under development, and we did not want to overburden them with security policies. So basically, we actually just applied anti-malware and web reputation. We did not set up firewalling, we did not set up intrusion prevention, we did not set up integrity monitoring, we did not set up log inspection, and we did not set up application control. And you see, when we talk about security, this is all the capabilities that you should take into account. When you say, is my system secured? Well, there is the aspect of firewall, intrusion prevention, and all of those aspects. So you need to make sure you have covered all of your bases. So just to show you that the risk you are running if this machine would be put in production without any changes and just simply anti-malware, let's switch to a little bit of switching here. So this is impossible to see. That should be a little bit bigger. Maybe can we dim the lights or something? No, we can't. Okay, so I will tell you what I'm doing here. So this is Kali. Kali is an oh, there we go. Is an attack, and well, maybe the ones in front are more important. So Kali is an attack environment, and we are using Metasploit as the exploitation framework. I'm starting it up right now. So it says it is starting. There we go. So I want to use, because it's a web server, so I want to use the Heartbleed vulnerability. So let's have a look what we have in store. Search Heartbleed. And so we have, for example, the first one, that's the one I'm going to use. Use auxiliary, scanner, SSL, open SSL, and then Heartbleed. And then show options. I need to also set our hosts to cdc web 1.greendisk.net. Yeah. So let me show you actually that host, what it is. So I go to here. And this is my web server. And let me zoom that back again. Yep, so there we go. So this is a vulnerable web application, something that we just use because it is vulnerable. So we use that to attack it. We are not going to attack a real website. So I am a normal user here. I just log in with user admin and with password. Let me show you. You can see password. I just log into that website and I am logged in. Nothing special here. Now I go back to my attack framework and I do zoom in. Yeah. And so there's one more thing I need to do, set verbose to true, because we really want to see something. And then I run the exploit, learn to type, Chris. So there we go. You see a lot of garbage here on the screen. So here I did launch the exploit. There is a client hello going on, handshaking going on, and so on and so on. And then because that server is vulnerable to Heartbleed, it actually bleeds, it dumps a block of memory of the server. And so that's all of this crap that you see here. Only when you really look closely, you can see here it says username equals admin and password equals password. So because that server is vulnerable to, in this case, the Heartbleed vulnerability, it can leak very sensitive data. Bad guys just program this in a loop, keep on sending the exploit to your server, and they get, every time they get different memory blocks. Now they had a username and password. Next time maybe they get your server's private key. Next time they get another user. And so this is, you're actually bleeding data there. It's very bad. So now let's take this server. It was still under development, so it should not have been reachable from the outside. So now let's put it in production. And this is an action done by the guys in operation, right? And they're not going to tell us about it. That's how they are. No, I mean, nothing bad about the operations people, but they have a lot to do. They have a lot on their mind. And in many cases, they kind of forget to involve the security guys. So they are going to take this web server, the one we just attacked, and we just drag it into the folder with web servers. And the convention is servers in that folder, they are in operation. Or maybe it's the acceptance testing environment or something, but that's where we could say now the server is in operations. Now let's have a look to what happens on the deep security side again. So we now see that in development we had 2 servers. There is only one now. And you can see at the bottom here there is an activation going on. So I now go to web servers, and that web server has been moved. Okay, obviously we know about this, but also the security policy has been changed. And now let's have a closer look. What happened without touching that machine? All of a sudden it has gotten a firewall and intrusion prevention and integrity monitoring, and I could have activated also the 2 other security controls, but I actually did not in this demo. So intrusion prevention is actually what is going to protect us now against the Heartbleed. So let's go back to my exploit environment. Okay, now I get here, lots of clicking, and now I zoom it again. So you can actually see it, okay? So I run the exploit again, the same command as I did before. And so I have all this gobbledygook here. It is sending the exploit. And then at the bottom, come on, oh, crap, sorry. So at the bottom we see, that was the previous one. Come on, It's this Zoom product, so I need to set my cursor here, and then I zoom again, and now you can see it, yeah. So we did send the exploit, and nothing came back. So to the outside world, it looked like, you know, this server was protected. It is not vulnerable to this exploit. And me as a hacker, I just hit, you know, I'm not getting in. I can't do anything. And all of this, again, we did not touch the machine. Everything was automated. And this is all that thanks to the tight integrations that your security product needs to have with your operational side of things. So, switching back to the slides. I will skip a few slides now because they were all in the demo. So, some high-risk vulnerabilities. Lately, we have seen Eternal Blue, which is the vulnerability behind Petya and WannaCry. And so, that's a high-risk one. I did show you the demo on this website that was put in production, and it was not protected. And so there is a video in the PowerPoint, and when you download it, you can see that. Now the question is also, we applied intrusion prevention rules, but how on earth are we going to know, or is the system going to know which IPS rules to apply on which server? And for that, you need something which we call a recommendation scan, and it is actually a kind of vulnerability scan. So when you put a machine in production or on a regular basis, you can say, I want to verify what vulnerabilities exist on this machine. So in deep security in the product, you configure what we call a recommendation scan, and it will scan the machine for vulnerabilities. It will produce a list of all the vulnerabilities that the machine has, and if you want to, it can automatically apply virtual patches to that machine. So it actually blocks the exploits, the vulnerabilities that are available on the machine. So next step about protecting, also that part was in the demo. We showed the machine was protected automatically through all those layers of security, those 8 different layers of security. Don't limit yourself and say, okay, we have antivirus or antivirus plus intrusion prevention. You need to make sure that you cover as wide as possible your security controls. And then, well, the game isn't over yet. When that machine is in production, we need to make sure we can maintain it, because in reality, the environment changes. We have new vulnerabilities being detected. We have new 0 days being detected, so we have to make sure that our environment gets the latest protection, and preferably in an automated way. And the other thing is, we think we have set up this server and we say it is secure, but probably after us, somebody can go and install new software on the server and introduce new vulnerabilities. So for that, there are 2 additional controls that are very cool or very interesting to make sure that your server remains protected. One of those is integrity monitoring, which actually monitors permanently your server or your workload for changes that are made in sensitive files. If somebody would go and change your httpd.com file, the configuration file of your web server, and maybe turn off SSL requirement, or somebody would go into the registry of your Windows machine and make some changes to sensitive keys. Well, all of this is detected by integrity monitoring. So you will see, this is my server, I put it in production, but now it's drifting away from my initial setup. Somebody is making changes, I know about it. Application control, somebody would be installing new software. And software, we see that pretty broad. It can be an executable, it can be a script, it can be a PowerShell script, it can be a Python script, it can be a Bash script. somebody is adding new scripts to the machine, well, application control will detect that and will make sure that the new software is not able to run until you authorize it to run. So this kind of freezes your server when you put it in production and makes sure it remains the same server as you configured. So this vulnerability scans is actually, and this is the little segue into making the business case for automated virtual patching. So the idea is, in the product you configure to run a vulnerability scan or a recommendation scan, as we call it, to run that like once a week, or on your very sensitive servers you can say, I want to run it once a night, every night. So you run the scan, it tells you the vulnerabilities, and it automatically applies the patches for that, so they cannot be exploited. So this is the business case for automated virtual patching. What we typically see when we talk to enterprises, the way they do their security patching, they patch maybe once a month. They do critical patches, and twice a year they do full patching. Is that something you can relate to? Is that something you see in your environment? Yeah? At least one person? Okay. So of course this may change depending of your risk appetite and the market you are in, and you know, the environment. But typically we see, like every month you do your high risk patches, and then like twice a year you do the full patching. Now with automate, okay, now one step back. What happens when a new zero-day surfaces, like we had with Eternal Blue or Shell Shock, which was, Heartbleed, which was in the demo? What happens? So we're all running around with our hair on fire because we have to figure out what is our exposure, what is our risk. Are we vulnerable? How many servers are vulnerable? Who will provide the patch, the physical patch? When can we have the patch? We have to scramble a team that can test the patch, because we're not going to patch just real time in production. We really want to test it before we put it in production. Then you need to talk with operations to get a maintenance window and actually put the patch in the production environment. Now that's all high impact. And typically when you have new 0 days, if you, in like a mid-size or a big-size organization, if you can patch in like 5 days, that's like an achievement. Some organizations can patch in 24 hours for really, really high-risk things, but that's like more like an exception. So 5 days is what we typically see as a normal period. Now, take a look at automated virtual patching. Like every week we schedule the recommendation scan, and based on the outcome of that, we automatically apply the patches. Or for our high-risk servers, we set this up to run like every night. So the result is, to the outside, it looks like you're patching like, yeah, you can hardly see the little needles here, but you're patching like every week or every night on your high-risk servers. So why is this a win-win? Well, because this automated patching, it's all automated. It's almost all hands-off. You schedule it, it runs, it gives you the results, and if you want to, it can automatically apply the policies. Now, depending on your organization, you might not want to automatically apply those IPS rules. You can set the system up so they are applied in detect mode. So they will alert you if somebody is using that vulnerability, if somebody is exploiting that vulnerability. You will get an alert, but it will not block you. So some enterprises feel a little bit more comfortable with that. So they run the system in detect mode for a couple of days or weeks, and then when they see there are no false positives, they say, now we feel comfortable, we are going to move over to protect mode, to blocking mode actually. And that's simply a flip of a switch. You can do that on a policy basis, on a machine basis, or globally if you want to. So the business case here, You see the window of opportunity for the bad guys here with new vulnerabilities is like one month here. You're patching every month. Here the window of opportunity becomes 1 week or even 1 day. So you are increasing, you are raising your security posture. On the other side, because you can actually now skip those monthly updates because they are automated, so it reduces your operational cost. So basically, this whole process, if you set it up correctly, it can be a win-win. It wins you on one side because your security goes up, and on the other side, it can lower your operational costs. So really, this is something, if you don't have that yet, you really have to take a look at. Now, we just said, you can patch for high-risk vulnerabilities like within 5 days. Is that okay? Well, this is a screenshot that was sent to us by one of our customers, and they said within 5 days after shell shock, 766 attacks were already blocked by the deep security product. Now, they do have a number of machines running there and so on, but the question is, if you are patching within 5 days for critical vulnerabilities for 0 days, the question is no longer will we be exploited and hacked, the question is just how many times will we be, because 766 attacks blocked, that's a lot. And even if after 5 days you close the door and you say, okay, we dodged the bullet, we have not been compromised, I have now applied the security patch. Well, how do you know you have not been compromised? We typically see that when new 0 days become available, so to speak, the bad guys, they start attacking everything they can, and they just plant a little back door in your environment. And they don't do anything. They don't make any noise, so it all remains like under the radar. And then after a few days, you do your physical patching. If you're not using virtual patching, you do your physical patching. You say, the door is now closed. I dodged the bullet. Well, you didn't, but you don't know. Afterwards, they don't need that vulnerability anymore. They can just activate their back door and start attacking your environment through lateral movement from the inside out. So that's an important thing to keep in mind. Even after 5 days, you're never sure that nothing happened. And that's a real, a real example from a customer here. So now let's, get the feet a little bit more on the ground, and let's go to Plexus. So
thanks, Chris. That was great stuff. So 5 years ago, when we first implemented Trend Deep Security, there were really 3 things that we had in our story. It was all about performance, it was about security and cost, right? By taking that antivirus client and offloading it to the hypervisor, you were able to actually reduce the scan storms so that you would have a better performing hosts. You would be able to reduce your attack surface by taking that off of the client, putting it at the hypervisor. Also, you'd get increased density, right, at that point, because you could load more systems per host. Today, we consider that more table stakes, right, as we move forward. It's really about how do we integrate with our existing ecosystem so that we can choose the best of breed for all the technologies in order to provide the best protection mechanism, right? And this gives us flexibility. So with all these APIs, we're able to respond better and innovate because the bad guys aren't going to stop their innovation, right? So when you think of things holistically, as you're looking at your security framework, it's useful to consider someone else's security framework, right? NIST, National Institute of Standards and Technology, has a framework that, while it calls out to like the NIST special publications that are used by the government, it also calls out to ISO, right? With frameworks like this, you see different products and tools that kind of pop up to help us protect our environments. If you look at the bottom bubbles here and compare them with the 8 layers of protection that Chris had gone through earlier, there's a lot of great overlap there. The other thing that I wanted to make sure that I pointed out was, as you're looking at this process, right, look at the improvement phases in your respond and recover. After you have an event, whether it goes good or bad, make sure you take that feedback and continuously improve, right, so that you can spend more time automating your response plans so that you can be protecting and detecting, right, instead of actually spending all that time recovering. Out of the box, Trend Deep Security has a lot of the straightforward mechanisms that we're used to seeing, but maybe we haven't implemented the hooks into our environment. Syslog, right, if you're Splunk or if you're using vRealize Log Insight, to be able to do that log correlation. It's useful to have. SNMP, of course, to be able to integrate with any existing monitoring solutions. Do what it takes, right? If you have to go to email because that's what's in front of everyone, do it, because getting the security events in front of people is going to be very important. We'll also talk a little bit more about vRealize Suite, especially the operations part, and how that would integrate. NSX integration. NSX integration with Trend Deep Security, you're talking about these security tags that are on the lower right-hand side of the screen, right? When you detect some sort of threat, the best case scenario is that you isolate that off, right? And prevent anything coming in and out. Sometimes our SLAs don't always permit that, especially in the low level, just kind of possible threats. That's where you might consider things like blocking out the outbound access to the internet. Stop it from phoning home back to these command and control systems. Also combining this with the NSX native integration to be able to talk to your domain controllers and be able to do an identity-based firewall. You see that a domain administrator logged into a system and that system has some sort of threat. Prevent a resume generating event by blocking everything outbound while he's still on that system, right? VMware we talked about as the glue for stuff, right? It's kind of that middleware. With Orchestrator, that's really the glue that VMware has in order to do things like look for new tags, new systems that are tagged, do things like take snapshots of systems that you suspect are infected, be able to take clones of those, take live clones that you can actually do additional forensics on. Prepare your restores. Get additional scanning in place. There's a great demo from a little while back that also includes the source code for Orchestrator in order to go through and take a snapshot of a system that has been tagged, put RSPAN port on it, write a tap onto it in order to have a second virtual machine that has Wireshark running on it to be able to see in detail what exactly is that system doing. As you're going through and you're developing your response plan, one of the things you probably are going to wonder is, what does a high, medium, and low threat mean? Talk to your security teams, right? Or if you don't have a security team, maybe at least talk to your boss. Look at Trend Micro's threat encyclopedia. You'll see a lot of examples for current day things that you see in the news and what level of threat they were chosen at and why. So it's a good tool to have in your back pocket in order to understand these systems. As you develop and mature your response plans, take a look at the GitHub repository for Trend Deep Security. Great resource for seeing how does the REST API interact. There's Python and PowerShell examples there. As promised, vRealize operations. What does it look like? Before the Trend Deep Security integration into operations, vRealize operations, you might have a user call up, and that user is going to call and say there's a slow system. The help desk administrator ties it back to a virtual machine and sends it off to the queue for the virtual machine administrators, right? The junior admin probably picks up the ticket, looks at the system inside of vRealize operations and says, yeah, it's running hot on CPU. We'll move that over, vMotion it to avoid some noisy neighbor problems. Maybe we'll reboot the virtual machine. Maybe worst case, we actually go through and we recycle that virtual machine, right? Reprovision. After he's done, closes the ticket. Root cause analysis looks like maybe there was some corruption. On the other side, though, when there's a security administrator looking at it, what is he going to see, Chris?
Yeah, exactly. So, am I off? Okay, so exactly. So if that ticket comes in, depending on the context, somebody can decide, oh, it's a security incident. We will hand it over to like the security team, and they will look at their security dashboard and analyze everything from a security perspective. Like if you are a hammer, everything looks like a nail, right? You just look what you are, you just see what you are looking for. And so that's the thing. Either the ticket goes in through the traditional way, or it goes in through the security way, and there are no links in between. There are like big silos and big walls, and every group analyzes it in its own way. Now, because we value integrated security and we value integration very high at Trend Micro, and we are like the #1 partner with VMware. So we have created an adapter for vRealize operations, so it can actually read the security events from deep security. So now, if a ticket comes in and you have this set up, the administrator will go and look into his VROPS dashboard. They will see the events, operational events like high CPU on the server, like high network traffic, but also in the same screen they will now see there was an attack on that machine. There were intrusion prevention rules triggered and alerts generated. There was, an attack on the machine. So this is an example, like in I need to use the pointer here. So on the graph on top, you see, for example, a spike in network connectivity, or in this case, a CPU connectivity. And in the graph at the bottom, you see at the same time, there were a lot of IPS events generated. So now you can correlate this and you can say, well, the slow server that we saw was not because there was something wrong with the machine, but it was actually under attack, and we can prove this by correlating the data between both graphs here. And we just remain in our vRealize operations dashboard. We don't have to switch back and forth between different dashboards and then in the back of our mind try to correlate everything. We now see that in one single dashboard here.
So some of the things that we've learned over the last few years doing different deployments, with their most recent deployment of the Deep Security 10, I would like to point out the Trend Best Practices Guide. In past years, I could have probably spent 10 slides just talking through all the different best practices that have come about, but Trend's really upped their game with the documentation. Take a look at it. There's a lot of great diagrams describing for sizing in different situations, with different virtual machine to vCPU type ratios. What do you need? How do you test these things without using Metasploit or something like that? How do you do some sort of best practices around architecting your environment? What are the recommendations out there? A lot of the focus that we had in stumbling around was considering remote sites, right? If you have a remote site that has a great deal of bandwidth out to the internet, and maybe your WAN connectivity back and forth is strong, consider putting some additional distribution points out there, right? So that site remotely is getting its signatures through that fat pipe instead of the slow path back. Also with the managers, make sure that you're considering, okay, with deep security virtual appliances, these are appliances now. If I run into a problem with a deep security virtual appliance, I don't want to be sitting there monkeying around at the command line trying to figure out what's wrong while that host is potentially at risk. In the cattle versus pets analogy, treat them as cattle, right? Just destroy and redeploy. For that, you have to make sure that your managers have a decent bandwidth back to those systems, right? Or deploy a second manager. Plan your firewall rules. Nothing's worse than having a situation where you firewalled off entirely your vCenter or your NSX manager or your deep security system so that you're not able to get back into there and actually troubleshoot something there. Plan your affinity rules. Make sure that your Trend Deep Security database is always close by to your Trend Deep Security manager. Also plan to pin your deep security virtual appliances to each of the hosts that they're actually protecting. Plan your restarts, right? Whether it's a short restart and you're just doing some maintenance on a host, and the first thing that comes up is the deep security virtual appliance before you start powering up all those virtual machines. In a wider case where you're doing maybe larger maintenance and you're bringing up first vCenter, then your deep security manager, then your database where you're the NSX manager, then the deep security database, and then the deep security manager, right? Make sure that you know exactly what that looks like, especially for your junior admin, so that they know what this needs to come up when. I also wanted to point out that today, and I'm told this is being worked on, and we should see something pretty soon, agents are needed for Server 2016. Agents are needed for Unix virtual machines. But chances are, if you want to leverage some of the more advanced machine learning, the behavior-based analysis, you're going to want that agent on each of your virtual machines anyway. So keep that in mind. The other place I'd really recommend that you put agents is on your Windows-based components that are supporting your deep security system, right? Again, we have that circular dependency where vCenter needs to come up first before, as well as the database before NSX comes up, and before you actually are able to have deep security virtual appliances protecting your system. You don't want that gap in time. Finally, the last thing I wanted to talk about was get to know VMware tools. If you're using the agentless protection, know that there are 2 different introspection drivers that are in charge of this. There's a file introspection driver. There is a network introspection driver. The file introspection driver is really the one that's key for anti-malware. The network introspection driver, not so much. And we found that the TDI hooks into Windows sometimes cause problems. Be especially aware of problems in the 10.0.0 through 10.0.0.7. Take a look at the versions file and the packages link at the top there. It describes specifically what version goes to what build, and then you can look at what build number goes to which version, which patch level from that VMware KB article. Ensure that you're keeping up to date on your VMware tools installs, right? Automate the process. The command line there is something you can put inside of your vSphere web client to automate the process of updating VMware tools and getting rid of that network introspection driver if that's causing problems, or you can omit that portion, right? Also consider suppressing the reboot if you don't want to deploy that and have it reboot before your maintenance cycle. Finally, in summary.
So, so far I have not talked about agentless or agent-based because I think in my mind it's not really that relevant. But Kelly mentioned it, and maybe I should just spend a few words on that. If you are running the full NSX, the NSX Advanced or the Enterprise version, then you can protect your machines fully agentless, which gives you higher integration and with NSX, which gives you, you can leverage more NSX capabilities. It gives you higher performance because we can do a scan cache, and maybe in the interest of time, we are close to at the end of the session. If you want to know about that, just come to our booth and we can talk more about this. If you would not buy into the NSX Advanced or NSX Enterprise because maybe it's too expensive or whatever, you can go and install an agent. This is not something you have to do manually. This can be taken into the automated process. Agents can be deployed through scripting, through bash scripting, or through PowerShell scripting. It can be integrated in your automated deployment cycle, and whether the machine has an agent or not, basically it does not make a lot of difference in the way you operate, in the way you work. Depending on your environment, you can opt in for one or for the other choice, but you know that's when you look at capabilities, it doesn't really matter if you go agentless or agent-based. The main thing here is you need to make sure that the solution is integrated and automated. And for me, that's the key value of this presentation. If security is an aftermatch, if security remains something you bolt on after the fact, then you will always get into trouble. Because the last thing is the first thing that is often forgotten. And if you forget to apply your security, then you know you're in trouble, or you can be in trouble. So Automating security, make sure you integrate, make sure you have full visibility. We talked about shadow IT, we talked about unprotected VMs that do not show up in your security dashboard, so make sure you have a full coverage. When we talk about protection, make sure you have all the possible layers applied that you can have. It's not about applying the rules, but making sure they get top-notch all the time, so you need to regularly reevaluate the security of the machine. We covered a little bit on the business case for automated virtual patching, and again, I can't stress it enough, this is like a no-brainer. It increases your security and it lowers your cost, so why shouldn't you go for it? And if you want to get more details or get a more into detailed demo or something, come to our booth. We'll be happy to talk about more in depth about this. So with that, I think we should wrap up. I hope you had some value out of this, whether you buy into NSX or not, you buy into deep security or not. I hope you had some value from this session. Thank you.